Octopuses are extraordinary creatures, often referred to as the aliens of the sea, due to their unique biology and intelligence. Their abilities continue to fascinate scientists and nature enthusiasts alike. Two-thirds of their neurons aren't in their brain, they're in their arms. This unusual distribution of neurons allows them to process information locally without needing to rely on their central brain for every decision. This means each arm has a mind of its own. Imagine having 8 highly intelligent limbs that can think, feel, and act independently. That's the reality for octopuses. Each arm can explore, solve problems, and even react to danger autonomously. Scientists discovered this distributed nervous system through careful observation and experimentation. By studying their behavior in controlled environments, researchers uncovered the remarkable autonomy of their limbs. They found that severed octopus arms could still perform complex movements and responses to stimuli, even without a brain to direct them. This discovery was groundbreaking, showing that intelligence can exist in a distributed form. This revelation challenged our understanding of intelligence, suggesting that it doesn't always reside solely in a central brain. Instead, intelligence can be spread across different parts of the body, working in harmony. This decentralized intelligence offers octopuses incredible flexibility and adaptability. They can quickly respond to their environment, whether it's squeezing through tight spaces or evading predators. They can multitask effortlessly, with each arm performing a different action. Simultaneously, one arm might be opening a shell, while another is feeling for hidden prey. This makes them incredibly efficient hunters and masters of camouflage and escape. Their ability to adapt and thrive in diverse environments is a testament to the power of decentralized intelligence. Each octopus arm contains about 40 million neurons, forming a mini brain that controls movement and processes sensory information. These arm brains are interconnected, allowing for communication and coordination between limbs. But here's the fascinating part. Even when separated from the central brain, these arm brains can function autonomously. They can reach, grasp, taste, and even remember simple tasks. This suggests a level of independent decision-making within each arm. This distributed nervous system allows for incredibly fast reflexes. When an octopus touches something interesting, its arm doesn't need to wait for instructions from the central brain. It can react immediately, grabbing prey or withdrawing from danger in a split second. The intelligence of octopus arms is perhaps most evident in their remarkable escape abilities. They can squeeze through incredibly tight spaces, open jars from the inside, and even use tools to achieve their goals. One study observed an octopus unscrewing a jar lid to reach a tasty crab inside. The octopus used its arms to grip, twist, and pull the lid, demonstrating impressive problem-solving skills. Another experiment placed octopuses in mazes with food rewards. The octopuses quickly learned to navigate the mazes, using their arms to explore different paths and remember the correct route. These examples highlight the incredible cognitive abilities of these seemingly simple appendages. The mimic octopus takes arm intelligence to a new level. This incredible species can change its skin color, texture, and even its shape to impersonate other marine animals. But what's truly astonishing is how the mimic octopus uses its arms to enhance its disguise. It can flatten its body and extend 2 arms to mimic a venomous, banded sea crate, complete with a swaying motion. This behavior suggests that the octopus's arms aren't just following pre-programmed instructions. They seem to understand the concept of mimicry and can adapt their movements and appearance accordingly. This level of sophisticated imitation requires a remarkable degree of independent thinking and coordination between the arms. The suction cup, it's truly a marvel of nature. These tiny, intricate structures are not just for sticking to surfaces, they are gateways to a world of sensory information. Octopus arms aren't just intelligent, they're also, well, incredibly sensitive and dexterous. They move with a fluidity that seems almost otherworldly, adapting to their environment with ease. Each arm is covered in hundreds of suction cups, and get this, each of those suction cups contains thousands of chemical and mechanical receptors. Yeah, thousands. These receptors allow the octopus to gather an astonishing amount of data about its surroundings. These suction cups allow octopuses to taste their environment, detecting chemicals and textures that, honestly, we can only imagine. It's like having a built-in sensory toolkit, perfectly designed for underwater exploration. This gives them such an incredibly detailed understanding of their surroundings. It's almost like having a superpower. They can map out their environment in ways that are beyond human comprehension. The combination of all that sensory input and their ability to control each arm independently allows for some pretty amazing dexterity. Each arm seems to have a mind of its own, working in perfect harmony with the others. I mean, they can manipulate objects with incredible precision, like unscrewing lids, opening shells, and performing tasks that require both strength and finesse. They've even been observed using tools to access food, showcasing a level of problem-solving that's rare in the animal kingdom. It's absolutely fascinating, isn't it? The octopus is a true testament to the wonders of evolution, blending intelligence, sensitivity, and dexterity in ways that continue to amaze us. Learning from the octopus, we find ourselves diving into a fascinating realm of bio-inspiration in robotics and artificial intelligence. The octopus, with its extraordinary abilities, has become a symbol of innovation for scientists and engineers. Its unique biology and behavior inspire us to rethink how we design and build machines. The unique intelligence of octopus arms has, well, truly captivated scientists and engineers alike. These arms operate semi-independently, showcasing a level of autonomy that is rare in the animal kingdom. This autonomy is what makes them so fascinating to study. With their decentralized nervous system and those incredibly flexible, adaptable limbs, octopuses offer valuable insights for developing new technologies. Their ability to manipulate objects, solve problems, and adapt to their surroundings is unparalleled. This has sparked a wave of innovation in robotics, where flexibility and adaptability are becoming key design principles. Traditional robots, as you might know, often rely on centralized control systems, which can make them less adaptable to unpredictable environments. These systems, while effective in structured settings, struggle when faced with dynamic or chaotic conditions. But by studying the way octopus arms function, researchers are now developing robots with more distributed intelligence. These robots are designed to mimic the octopus's ability to process information locally, allowing for quicker and more efficient responses to their surroundings. This allows these robots to react and adapt far more effectively. They can handle irregular objects, navigate complex terrains, and even perform delicate tasks that were once thought impossible for machines. This bio-inspired approach honestly has the potential to revolutionize so many fields: search and rescue, underwater exploration, and even healthcare. Imagine robots that can reach into tight spaces during a rescue mission or perform intricate surgeries with precision and care. In these areas, robots really need to navigate complex and dynamic environments, and the octopus is showing us the way forward. By embracing the lessons nature has to offer, we are not just building better robots, we are redefining the future of technology itself. Another area where octopus arms are sparking innovation is in the field of soft robotics. Unlike traditional robots, which are often, well, rigid and inflexible, soft robotics takes inspiration from the octopus's incredible flexibility. Octopus arms can squeeze through narrow openings and manipulate objects with remarkable dexterity. And that's something traditional robots just can't do. By developing soft robots inspired by these arms, engineers are creating machines that are not only safer but also more versatile. these robots are better equipped to handle delicate tasks. This technology honestly holds enormous potential, especially in medicine. Imagine soft robots being used for minimally invasive surgeries or even assisting with rehabilitation. It's an exciting frontier, and it's all thanks to the Octopus. The Octopus's decentralized intelligence, well, it really challenges our traditional understanding of how brains work. We often think of intelligence as something that resides solely in a central brain, don't we? But the Octopus shows us that intelligence can actually be distributed throughout the body. This raises some fascinating questions about the nature of consciousness and decision-making. If an octopus arm can, in a way, think for itself, what does that mean for how we understand intelligence? The example set by the octopus suggests that intelligence might be far more fluid and adaptable than we've previously thought. It might not always require a centralized brain and could even manifest in forms we never imagined. It's, well, food for thought, isn't it? Food. The octopus, with its 8 intelligent arms, offers us a glimpse into a world brimming with possibilities. By studying these fascinating creatures, we're not just learning about their unique biology, we're also expanding our understanding of intelligence, adaptation, and honestly, the vast potential of the natural world. As we continue to explore the depths of our oceans, who knows what other mysteries and marvels await us? The octopus reminds us that there's still so much to learn from nature itself. And really, isn't nature the greatest innovator of all?